Good afternoon, and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, I want us to discuss example 13 of chapter 3 or chapter 6 rather of Pure Mathematics 3 International Advanced Level Specification. And we have just learned the quotient rule, which we are going to outline or to highlight still in this video. And the question is a curve C with the equation y is equal to sine x over e raised to power 2x, of course within the range of x between 0 to pi, has the stationary point at P. Find the coordinates of P and give your answer to three significant figures. Of course, when we have now the function in this nature, you can only, let's write it here, y is equals to sine x over e raised to power 2x. At that particular point, you can already see that u is sine x and du dx is obviously the cosine of x. At the same time, v is e raised to power 2x and dv dx is going to be 2 e raised to power 2x. That we know. And of course, because we are talking about a function that has a numerator and a denominator, we have no choice apart from simply using the quotient rule. But what is the quotient rule? Using the quotient rule, dy dx becomes the denominator v multiplied by the derivative of the numerator du dx minus the numerator u multiplied by the derivative of the denominator dv dx, everything over the square of the denominator. And that is our quotient rule. And remember, in this particular question, we are expected to give the coordinates. So we must get the specific value of x and the specific value of y at the turning point P. Now, let us first of all evaluate dy dx, or rather the gradient in general. Dy dx becomes v, which is v is e raised to power 2x, that is e raised to power 2x, multiplied by the du dx, which is the cosine of u. Of course, that with that goes with that, minus that goes with that. Of course, this minus this. So we are talking of the cosine of x minus the u, which is the sine of x, multiplied by the derivative of v, which is 2e to x. All this is over v squared e 2x squared. And at the end of the day, we must look at this. Keenly, and because we have e raised to power 2x, which is also common here, let it be outside e raised to power 2x. Inside the bracket, we must talk about the cosine of x minus 2 sine of x. Everything over, you clean up the denominator a little bit and you have e raised to power 4x. Having done that, you will agree with me when I say that dy dx is given by, of course, we have e raised to power 2x and e raised to power 4x. Using the laws of indices, those will have to cancel out. 2x minus 4x is negative 2x. So e raised to power minus 2x multiplied by the cosine of x minus 2, the sine of x. And at that point, because that is the derivative, then we will have to remember what happens at the stationary point. It has to be remembered by all and sundry, and we say at stationary point dy dx is supposed to be equals to 0. And if that is true, and of course we need to express ourselves into this kind of way, and remember that if this is true and dy dx is just this, then it follows that e raised to power minus 2x cosine x minus 2 sine x is now what is equals to 0. If this is true, it is either that e raised to power 2x, it is either that e raised to power minus 2x is 0, and if this is true, of course you know e raised to power minus 2x can never be 0. We were with you when we were sketching the graph of exponentials, and the graph of exponential did not touch y is equals to 0. In fact, it has an asymptote along the line y is equals to 0. So this is obviously not possible. This is not practical. So if it is not practical, then not possible, or rather it has no solution. You can write anything, has no solution. It has no solution. So it is not possible that it is that part that is equals to 0. So definitely it is the cosine of x minus 2 the sine of x which is 0. And if this is true, 2 sine x is equals to the cosine of x. Again, divide by 2 cos x, divide by 2 cos x, so that we can have the tangent of x to be equals to a half. If the tangent of x is equals to half, and we are told to give our answer in radians, then 0.5, then we're talking about 0.5, and shift tan answer is 0.464. So x is going to be 0.464. Having realized the value of x, what is the value of y? Because for us to give the coordinates of point P, we have to give the value of x as well as the value of y. So we say when x is equals to 0.464, y itself happens to be, we need to substitute this in the original function, the sine of x all over e raised to power 2x. And what is that? Let's just talk about, we had the sine of 0.464, fine, everything over e raised to power 2 times 0.464. And of course, after we evaluate everything, we get 0.177. So y is 0.177. And that is the value of y at point P. So when we are giving now the coordinates of point P, we say P is having coordinates of 0.464 and the value of y is 0.177. Somebody talked about to three significant figures, and there we are. Those are the coordinates of point P. Fine, it's quite an important question. Let us make follow-up. But of course, the very initial step is the derivative of this fraction. We must use the quotient rule, and this is just that minus that, and everything else follows suit. Also remember, at the stationary point, the derivative dy dx, which has been realized up there, is always equals to 0. Everything else will fit into place. Again, visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Share widely and of course subscribe. All right.